Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled The Bay of Rainbows. So what do we see here? Well, here we see an image of a small portion of our moon, and we're looking toward the northwest portion of Mare Imbrium. Now, what does that mean? Well, we're using the Latin word for sea, and this Maria, the smooth areas on the moon, are called seas. Now, that's a very historical thing when we might have looked up at the moon and thought that those smoother areas, darker areas, were actually pools of water on the moon's surface. Of course, today we know the moon is almost completely dry and airless and could not have liquid water on its surface at all. But you still may get that kind of resemblance when you look up at the moon. And of course, the naming convention has remained. Now we can see this off towards the left side of the image. In the top, we can see more cratered areas that were not flooded by the lava. So the Maria were formed when ancient impact basins were flooded by lava from the interior. Now, that was done about 3 to 3.5 billion years ago, and what we see is the differences in structure that occur over that time. The older areas are very heavily cratered, many times with craters on top of other craters. Whereas when we look in the section to the lower right, we see very few craters, just a very smooth lava flow with even some ripples where the lava solidified many billions of years ago. Now, there are some craters there, but you can see the very big difference between craters when you look from the Maria, the very smooth area, into the other regions. So some of those have craters that are on top of other craters and very worn out craters. The craters in the Maria look relatively new. Now, they're not necessarily brand new because they could still be billions of years old. There are no erosional processes on the moon that go fast like there are on Earth. We have wind and water that wear down craters, whereas on the moon, the craters just remain and will still look today as they looked millions of years ago. So just the fact that we see any craters there, we can't really just immediately tell an age from a single crater. However, when we look at the crater density, how many craters there are per square kilometer, we can use that as ways of dating and figuring out how old various regions of the moon are. And that is used across the solar system to determine ages, because the only other way to get ages is to actually have samples of the rock. Now, when you do have samples of the rock, then you can use radioactive methods to be able to determine the actual ages and get very accurate direct ages. But while we have some lunar samples and we may have samples we can test from a few other objects, it's very rare. So in most cases, we have to use those as kind of a calibration technique and then look at crater counts, because that then allows us to look at other objects around the solar system to really help determine ages, because the cratering was roughly the same throughout the solar system. So if we look at a heavily cratered surface, we can tell that it is very old. It has been around since the early times of the solar system. The fewer craters we see, the younger that surface is, the more it is worn out and reworked by weathering effects and perhaps volcanic or other tectonic activity. So here we can see two of those different regions on the moon, one much more heavily cratered, one with very few craters, allowing us to see a distinct difference in the ages of these two portions of our moon. So that was our picture of the day, titled The Bay of Rainbows. We'll be back again tomorrow for the next picture, previewed to be Friends of Andromeda. So we'll see what that is about tomorrow. And until then, have a great day, everyone, and I will see you in class.